Hello everyone, welcome back to the channel. In today's lecture, we are going to discuss the fourth and final pillar of object-oriented programming, known as abstraction. Abstraction is one of the most powerful concepts in OOP because it helps manage complexity in large software systems. While encapsulation focuses on data protection, inheritance focuses on reuse, and polymorphism focuses on flexibility, abstraction focuses on simplicity and clarity. By the end of this lecture, you will clearly understand what abstraction is, why it is needed, how it works, and how it is used in real-world and software applications. Abstraction is the process of hiding internal implementation details and showing only the essential features of an object to the user. In simple words, abstraction means what an object does, not how it does it. It allows programmers and users to interact with complex systems through simple interfaces without worrying about the internal working. Abstraction helps reduce complexity and makes software easier to use, understand, and maintain. Modern software systems are extremely complex. If users or programmers had to understand every internal detail of a system, development would become slow and error-prone. Abstraction solves this problem by separating interface from implementation. It allows developers to focus on what a system should do rather than how it should do it. This leads to better productivity, cleaner code, and fewer mistakes. Abstraction also allows teams to work independently on different parts of a system. To understand abstraction clearly, consider a car. When you drive a car, you use the steering wheel, accelerator, brake, and clutch. You do not need to know how the engine works internally, how fuel combustion happens, or how the transmission system operates. All those complex details are hidden from you. You only interact with a simple interface. This is abstraction in real life. Similarly, in programming, abstraction hides complexity and exposes only necessary functionality. Abstraction is not limited to programming. We use it every day. When you use a mobile phone, you tap icons to make calls or send messages without knowing how signals are transmitted. When you use an ATM, you withdraw money without knowing how the bank's internal systems process the transaction. These systems work efficiently because abstraction hides internal complexity and presents a simple interface to the user. Abstraction in object-oriented programming. In object-oriented programming, abstraction is achieved using abstract classes and interfaces. These constructs define what methods should exist, but do not define how they should be implemented. The actual implementation is provided by child classes. This allows programmers to define a standard structure while leaving flexibility for different implementations. Understanding abstraction with an example. Consider a shape concept. Shapes can be circles, rectangles, or triangles. All shapes have some common behavior, such as calculating area. However, the way area is calculated differs for each shape. Using abstraction, we can define a shape abstraction that declares an area calculation method without specifying how it is calculated. Each specific shape then provides its own implementation. This allows us to work with shapes in a generic way while supporting different behaviors. Abstraction and encapsulation are closely related, but not the same. Encapsulation focuses on hiding data and protecting it using access modifiers. Abstraction focuses on hiding complexity and exposing only essential features. Encapsulation answers the question, how is data protected? While abstraction answers the question, what functionality is provided? Together, they form a strong foundation for clean software design. The simplest way to understand abstraction is through the concept of what versus how. Abstraction tells what an object can do, while hiding how it does it. For example, a payment system allows you to make a payment, but it does not expose how the payment is processed internally. This separation makes systems easier to use and modify. Abstraction plays a critical role in software design. By defining clear interfaces, abstraction ensures that different parts of a system remain loosely coupled. This means changes in one part of the system do not heavily affect others. As a result, software becomes easier to maintain, test, and extend. Abstraction also encourages clean architecture and good programming practices. One of the biggest advantages of abstraction is flexibility. When software is designed using abstraction, new implementations can be added without changing existing code. For example, adding a new payment method does not require modifying the payment interface. Only a new implementation is added. This makes systems highly adaptable to changing requirements. In large applications such as banking systems, e-commerce platforms, and enterprise software, abstraction is used extensively. Databases, services, controllers, and APIs all rely on abstraction to separate responsibilities. Developers interact with high-level abstractions instead of low-level details, making development faster and more reliable. Abstraction is extremely helpful when multiple developers work on the same project. One team can define interfaces and abstract classes, while other teams work on implementations. This parallel development approach improves productivity and reduces dependency issues. Abstraction ensures that teams can work independently without interfering with each other's code. Abstraction promotes reusability by allowing common behavior to be defined once and reused across multiple implementations. When code is written against abstractions instead of concrete classes, it becomes reusable across different projects and use cases. This reduces development time and improves code quality. Abstraction and polymorphism work closely together. Abstraction defines a common interface, and polymorphism allows different implementations of that interface to behave differently. Without abstraction, polymorphism would be difficult to achieve effectively. Together, they enable powerful and flexible software designs. Common mistakes in using abstraction. One common mistake is overusing abstraction, which can make code unnecessarily complex. Another mistake is creating abstractions that are too generic or poorly defined. Good abstraction should be simple, meaningful, and closely aligned with real-world concepts. Developers should create abstractions only when they provide clear benefits. Abstraction is used everywhere in real-world software. Operating systems provide abstractions for hardware. Web frameworks provide abstractions for HTTP requests and responses. Database systems provide abstractions for data storage and retrieval. These abstractions allow developers to build complex systems without dealing with low-level details. In modern programming, abstraction is essential. Frameworks, libraries, and APIs are built on abstraction to provide flexibility and scalability. Without abstraction, software would be tightly coupled, difficult to modify, and hard to maintain. Understanding abstraction is crucial for writing professional quality code. Abstraction completes the set of object-oriented principles. Along with encapsulation, inheritance, and polymorphism, abstraction allows developers to build systems that are modular, secure, reusable, and scalable. These principles work together to form the foundation of object-oriented programming. To conclude, abstraction is a core concept in object-oriented programming that focuses on hiding complexity and exposing only essential features. It allows programmers to manage large and complex systems effectively by separating interface from implementation. Abstraction improves code clarity, flexibility, maintainability, and scalability. Mastering abstraction is essential for becoming a skilled and professional software developer. Thank you for watching this detailed lecture on abstraction in object-oriented programming. If you found this explanation useful, please like the video, subscribe to the channel, and share it with others. In the next lecture, we will combine all 4 OOP pillars with real-world examples and interview-oriented explanations. Until then, keep learning, keep practicing, and happy coding. Rocket generate the IMG.